Hello, and welcome to the first episode of the Data Engineering for Beginners series. I am Jansi, a data engineer with over a decade of experience in transforming raw data into valuable insights for some of the world's largest organizations. In this video, we are going to start from the very basics and lay a strong foundation for your journey into the world of data engineering. Whether you are a student, or a developer, or someone curious about this field, you are in the right place. Let's get started. So, what exactly is data engineering? In simple terms, data engineering is the practice of designing, building, and maintaining the systems that collect, store, and process the data. Think of it like this: when companies gather massive amounts of data from various sources like websites, applications, sensors, or transactions, they need a way to manage the data and prepare it for analysis. That's where data engineer comes in. They build the infra and pipelines that move data from one place to another and transform it into a usable format. Without data engineers or data scientists, wouldn't have the clean, structured data sets they need to build models or make business decisions. Why data engineering is so important? Now that we know what data engineering is, let's talk about why it's important. Today, every business decision is driven by data: marketing strategies, product improvements, customer engagement, and none of that is possible without reliable data pipelines. Data engineering ensures data is collected accurately from various sources, it is cleaned and validated, it is stored efficiently and made accessible for analysis. A robust data engineering setup is like a clean water supply in a city. It's invisible, but without it, nothing else can function properly. Let's see few of the roles and responsibilities of a data engineer. So, their core responsibilities includes building data pipelines, means moving data from source systems to data warehouses or lakes, or extracting, transforming, and loading the data, which is nothing but ETL. So, this should happen, the transformation should happen in the right format and load into the storage systems, or else monitoring the pipeline performance, like making sure data is up to date and consistent. Also collaborating the data, like working closely with the data scientists or analysts and software engineers. They also work with both batch and real time data, managing schema evolution and ensure security and governance. Now, let's try to understand what is data engineering versus data science. Many people confuse between these two. So, let's clear that up. Data engineers are like the architects and builders, they construct the data infra. Whereas data scientists are like the analysts or the consultants who use the clean data to find insights or build models. Let's compare from side by side. So, engineers focus more on infra, pipelines, and systems, whereas scientists focus on analytics and modeling. Engineers use tools like SQL, Spark, Airflow, etc., whereas data science people use Python, R, or any other ML tool libraries. Engineers deliver clean, structured, accessible data, whereas scientists deliver insights or forecasts and recommendations from the data. Both are very crucial roles, but they work at a different stages of the data life cycle. Now let's see what are all the key concepts in data engineering. To succeed in data engineering, you will need to understand some fundamental concepts. So let's explore those things. What is ETL versus ELT? ETL is nothing but data is extracted, transformed, and then loaded into a warehouse. Whereas ELT is data will be extracted first and loaded, then transformations will be applied inside the warehouse. And what is batch versus streaming? When the data is processed in chunks like daily or hourly, we call it as a batch data. Whereas the data is processed in real time continuously, like streaming live videos, that will come under streaming. And let's also understand what is structured and unstructured. So, structured is nothing but tabular formatted, clean data like an Excel sheet or a SQL databases. Unstructured data includes text, images, videos, or logs, which is less predictable in format. And let's see the last one, which is data lakes versus databases. So the data lake is nothing but raw data in any format, which is of great for flexibility. whereas warehouse is nothing but processed structured data optimized for querying, which is nothing but the databases. Now let's understand what are all the common tools and technologies that a data engineer commonly use. Like coming to the languages, they use SQL for querying the data, they use Python for scripting and automation, or Scala, often used with Spark, that is also for scripting. There are big data frameworks like Apache Spark, which is fast for distributed data processing, and Hadoop also, which is a large scale storage and batch processing tool or framework, we can say. For orchestration purpose, we go for Apache Airflow, where scheduling and workflows can be defined. There are many cloud platforms available like AWS, where S3 is generally used for storage, Redshift is used for warehouse purpose, and Glue is an ETL tool which is available on AWS services. Coming to Azure, Data Factory is an ETL tool that available as a service on Azure Cloud Platform, and Synapse is also for the similar purpose. Coming to the GCP, we see BigQuery and Dataflow, and there are many other services. These are only very few that I am listing out now. Also, for data storage purpose, we see Snowflake as a modern data warehouse. Also, BigQuery, Google serverless solution, Redshift is from Amazon. Likewise, we have many data storage solutions. So these are all couple of the tools that we use. As we go through the series, we'll get hands-on with some of these things. So let's say real world use case, let's consider Netflix. So how data engineering powers a real world company, Netflix. When you watch a movie on Netflix, the system captures every click, pause, rewind, and completion. All this is data, so which is ingested from user devices and transformed, aggregated into meaningful formats, stored in a data warehouse, and served to a recommendation engine. Without data engineering pipelines, the recommendation system would not work. The content we love to bing on is powered by behind the scenes data infrastructure. Let's see complete career roadmap. So if you are wondering how to get started into data engineering, here is a simple roadmap. Starts with SQL, learn to query the data, pick up Python for scripting and automation, understand ETL pipelines, concepts and tools, learn Apache Airflow for scheduling the workflow, and work with Spark to handle big data. Master cloud services, any one cloud service like AWS Glue, Redshift, or S3, and practice with one end-to-end project, so that with the help of public data sets from Kaggle or data.goe, anything. Don't worry about learning everything at once. Just take one step at a time. This series will guide you along the way. And that brings us to the end of today's video, a solid introduction to what data engineering is and why it's crucial. In the upcoming videos, we'll go deeper into each topic. Here is what's coming next. Like ETL fundamentals, learn how data flows in systems, building a basic data pipeline hands-on project using Apache Airflow, orchestrating the workflows, and data warehousing concepts for architecture, indexing, and partitioning, real-time data engineering using Kafka and streamline pipelines. If you find this video helpful, make sure to like, subscribe, and hit the bell icon to stay updated with the next episodes. Drop your questions or feedbacks in the comments. I'd love to hear from you. Until next time, keep learning and keep building. Thank you.